State and prove Rodrigue's formula. Rodrigue's formula is given by Legendre's function Pn of x equals to 1 by 2 to the power of n factorial d to the power of n by dx to the power of n of x square minus 1 whole power n. This is called as Rodrigue's formula, where Pn of x is called as Legendre's function. Pn of x, Legendre's function involved only in Legendre's equation. So that to prove this formula, first we have to prepare Legendre's equation using this function only. With the help of this function, we can prepare Legendre's equation. So that first we have to prepare LHS. Now, to prove LHS part, first we have to choose the function x square minus 1 whole power n as y. Now differentiate this with respect to x. First, dy by dx equals to, this is x power n form, n into x square minus 1 to the power of n minus 1. Again dy by dx of x square minus 1 is 2x. So that y1 equal to here 2nx, here n 2x, 2nx, x square minus 1 whole power n, x square minus 1 whole power minus 1. Out of this one has negative power, so the same step can be written as 2nx of x square minus 1 whole power n by x square minus 1. By cross multiplication, it will be y1 of x square minus 1 equals to 2nx x square minus 1 whole power n. So that y1 x square minus 1 equals to 2nx. The symbol for this is y. As per assumption, x square minus 1 whole power n assumed as here y. So that here y1 into x square minus 1 equals to 2nxy. Here this is the last step. Now to prepare Legendre's equation, now we have to differentiate this with respect to x n plus 1 times. N plus 1 times. To differentiate this with respect to x n plus 1 times, we have to use Leibniz formula on both left and right. So that here x square plus minus 1 first term as it is, n plus 1 times differentiation of second term plus n plus 1 c1 d of x square minus 1. Next n plus 1 times differentiation, next term is n times differentiation of y1 plus n plus 1 c2, here d square of x square minus 1, here n times over, after n times n minus 1 times differentiation of y1. Now after that equal to, here I considered only 3 terms. Why? Because here first time just x square minus 1 as it is, first time differentiation of x square minus 1 is 2x, 2 times differentiation of x square minus 1 is 2. If you go next step, the result is 0. 2 differentiation is 0. So this is the last step as per Leibniz. Now here on left hand side 2n into x y differentiation with respect to x n plus 1 times. So here also you have to use Leibniz formula. First term as it is, n plus 1 differentiation of y plus n plus 1 c1 as per formula, binomial coefficient taken as here n plus 1 c1 differentiation of x d to the power of n of y. Next one is, now d to the power of n plus 1 of y1 also represented as dy n plus 2 plus n plus 1 c1 value is n plus 1, x square plus minus 1 differentiation is 2x. Here it is y1 differentiation n times written as yn plus 1 plus n plus 1 c2 written as n plus 1 into n 2 by 2 factorial. Here as per NCR formula, n factorial n minus r factorial, according to this is equals to n plus 1 n 2 factorial. Next term is 2 times differentiation of x square minus 1 is 2. Next is d to the power of n minus 1 of y1 can be written as yn, that equals to 2n into x as it is, y differentiation with respect to x n plus 1 times written as yn plus 1 plus n plus 1. n plus 1 c1 can be written as n plus 1. d by dx of x is 1. Next, n times differentiation of y can be written as yn. Left and right differentiation over. After that, here x square minus 1 yn plus 2 plus 2x n plus 1 yn plus 1. The same step can be written as plus, here 2 get cancelled. Now the remaining value is n into n plus 1 yn minus here 2 nx yn plus 1 by writing these terms on left side 2nx yn plus 1 minus 2n into n plus 1 n equal to 0. Okay, after that next step is, here x square minus 1 d square, the same step can be written as 2 times differentiation of yn, the same yn plus 2 also written as 2 times differentiation of yn plus here 2x n plus 1. This is also written as 1 times differentiation of yn plus n into n plus 1 of yn plus 2nx. Here this is 1 time differentiation of yn minus 2n n plus 1 of yn equal to 0. After that, first term as it is, in these two terms yn dn of differentiation of yn as common, this is the next value, plus from these two which one has common, yn, this is the remaining value equal to 0. X square minus 1, this is the same can be written as 2 times differentiation of yn with respect to x also written as d square by dx square yn plus here 2n, first by ordinary product it will be 2nx plus 2x minus 2nx. Differentiation of yn, d of yn can be written as d by dx of yn plus n of n plus 1 as common from these two terms, then 1 minus 2 into yn equal to 0. Now by cancelling these two, the resultant value is x square minus 1 d square by dx square yn plus 2x d by dx of yn minus n into n plus 1 of yn equal to 0. But as per Legender's equation we need 1 minus x square, but here x square minus 1 is there. To get such equation we have to take out minus as common from every term. Then the first term will be changed as 1 minus x square d square y by dx square minus here minus 2x dy by dx of yn plus minus it will be changed as plus n of n plus 1 of yn equal to 0. The same equation also written as 1 minus x square d square z by dx square minus 2x into dz by dx plus n of n plus 1 of z equal to 0, where yn represented by symbol z. Just I considered in place of yn symbol z only. Now this is called as Legender's differential equation. Its solution is given by z equal to, as per note point, c into pn of x, where pn of x is Legender's function. Now z is nothing but yn, so you can write yn equal to c into pn of x. This is called as solution of Legender's equation. Pn of x we cleared. This is on left hand side of our Rodrigue formula. Next, to define c, we need c value. To get c, just you substitute x equal to a small number. I mean small number is nothing but to determine constant c, put x equal to 1 on both sides. Now yn of x my x equal to 1, c into pn of 1. As per note point, pn of 1 is 1, so that yn at x equal to 1 is c. Totally c value is yn of x minus x equal to 1. Here c equals to yn at x equal to 1. This is equation number 3. Now we need yn at x equal to 1. To clear this one, first we have to write to find the value of yn value at x equal to 1. To find out this one, first we have to consider given function again. Its name can be taken as y equals to x square minus 1 whole power n. Now x square minus 1 is a square minus b square form, so that a square minus b square also written as a plus b into a minus b. As per that formula, x square minus 1 equals to x plus 1 into x minus 1. Power is as it is. Now this is the power applicable for both, so that y equal to x plus 1 whole power n, x minus 1 whole power n. This is the given function. Now differentiate this with respect to x n times on both sides using Leibniz theorem. I mean n times differentiation of y left side, n times differentiation of right side. Now this is represented by yn equal to, there are two functions into u into v form is there. So first x minus 1 whole power n as it is, n times differentiation of second term plus nc1 into differentiation of first term, n minus 1 differentiation of second term plus and so on. Last term is ncn, n times differentiation of x minus 1 whole power n, x plus 1 whole power n as it is. Now here x minus 1 whole power n as it is, n times differentiation of x plus 1 whole power n. At the last ncn, n times differentiation of x minus 1 whole power n, x plus 1 whole power n. Now this is n times differentiation of right part. After that yn equals to x minus 1 whole power n. As per note point, n times differentiation of x power n or x plus 1 whole power n value is n factorial plus nc1 is n. Here differentiation of x minus 1 whole power n. Here this is can be written as n only x minus 1 whole power n minus 1. Next is n minus 1 differentiation of x plus 1 whole power n is here n factorial x, as per note point, n factorial into x plus 1. Okay, plus ncn d to the power of n of x minus 1 whole power n x plus 1 n can be written as here ncn value is 1. Here d to the power of n of x minus 1 whole power n, as per note point, if power same then its value is n factorial. Second term as it is. Once again differentiation x minus 1 whole power n as it is, as per note point, if same power is there, in this case n times differentiation of x plus 1 whole power n is just simply n factorial plus nc1 value is n. Next, one time differentiation of x minus 1 whole power n is, as per x power n formula, n into x minus 1 whole power n minus 1. This is n minus 1 is power, here n. For this one, as per note point, n minus 1 times differentiation of x plus 1 whole power n can be taken as n factorial into x plus 1. Next, at the last, ncn value is 1. Here same power, so that its value is n factorial only. Second term as it is. After that, by getting this, put x equal to 1 on both sides of above equation. Yn value at x equal to 1. Now here x 1 minus 1 is 0, first term 0. Here also if you write x equal to 1, this is also 0. Now here the complete term will be 0 at the last. Here this is only easier by writing x equal to 1. n factorial into x equal to 1 we considered. So 1 plus 1 whole power m. Totally on right hand side n factorial into 2 to the power of n. Now you can substitute this in third equation. Equation 3 we cleared. Now to get yn of x minus 1, we applied this procedure. Now yn of 2a, yn value at x equal to 1 obtained here 2 to the power of n into n factorial. So third equation is c equal to yn at x equal to 1, its value is n factorial into 2 to the power of n. Now you can substitute this in solution. What is the solution of Legender's equation? N equal to c into pn of x. Now c already we cleared, n factorial into 2 power n, pn of x. Now pn of x only one side, as per RODRIGUE formula, pn of x only one side, remaining terms are the opposite side. Yn is nothing but n times differentiation of y with respect to x. Totally pn of x equals to 1 by n factorial 2 to the power of n d power n by dx power n of y. This is called as RODRIGUE formula. To prove this formula, once again the first step is, first we have to prepare Legender's equation. From that we have to write Legender's equation solution, and then we have to write c value. After that yn we have to clear yn value at x equal to 1. Then only you can clear RODRIGUE's formula.